we will use a wave motion demonstration to explore wave properties of speed, frequency, and wavelength. My name is Aretha Smith, and I will describe the motion. Then, Vickie Williams is working on the left side of the demonstration, and David Bailey is working on the right side. On the right side, Vickie will use her thumb wrapped with fluorescent tape as the oscillating source of wave that will move through the yellow spot medium. This wave source is a single oscillation moving through the yellow dot medium of a constant speed. When the pulse reaches the other end of the medium, it reverses direction. This is called reflection. Now a wave consisting of a series of crests and troughs moves through the medium at constant speed. Notice that the yellow dot medium itself isn't going anywhere. Now on the left side, David is connecting a mechanical oscillator to the yellow dot medium. This oscillating source will create a wave moving in the opposite direction. We can call this the high frequency oscillation, and you can see for yourself how frequently it is vibrating. If anyone is counting, it is making 6 complete vibrations every 4 seconds. The frequency of the wave produced by the oscillation is the same as the oscillation's frequency. The distance between adjacent wave crests corresponds to wavelength. Alternatively, wavelength is also the distance between adjacent troughs. On the right side, David has positioned a meter stick with evenly spaced tape marks under the wave. For this high frequency oscillation, you can see crests popping up above each tape mark that alternate with troughs descending toward the tape marks. The distance between tape marks corresponds to wavelength. If someone has really good vision, they could read the meter stick and see the distance is 35 centimeters. This is a low frequency oscillation, and you can see for yourself that it is vibrating less frequently than the previous oscillation. This is the low frequency oscillation, and you can see for yourself that it is vibrating less frequently than the previous oscillation. If anyone is counting, it is vibrating 3 times every 4 seconds, half the frequency of the previous oscillation. For this low frequency oscillation, you can see crests pop up at the 2 tape marks at each end, and when this happens, there's a trough located at the middle tape mark. Similarly, when adjacent troughs descend toward the end tape marks, there is a crest located at the middle tape mark. So the distance between the 2 end tape marks corresponds to wavelength. With really good vision, you'd see this distance is 70 centimeters. So we have demonstrated waves created by oscillations. The high frequency oscillation created a wave with a short wavelength. Then the low frequency oscillation created a wave with longer wavelength. In fact, the second oscillation had half the frequency of the first and created a wave with twice the wavelength of the first. This concludes our demonstration.